So today we're looking at solving equations with rational functions, okay? So you're gonna notice we got some rational functions built into an equation and we're gonna solve them using one of three methods. So there are three different options for how you can do these, and it is really a matter of preference. So method one is my personal preference. That is what I usually go for, and that is what you're gonna see in all of your answer keys where I've done out the work for you. You'll see that I use method one. Okay, so method one is just get rid of all of your fractions. And it's very similar to what you would do, if you were solving just a regular equation with fractions, like if you had something like, 3/2 plus 4/7 equals 1/3, right? So let's throw an X in there so that makes sense. Okay, so if we were trying to solve this equation, right, you could take a look at this and say, well, the LCD of these three things would be 42, right? So multiply the entire equation by 42, and that'll give you something where you're not going to have any fractions left, right? You could do 42 divided by 2 is 21 times 3, so that would be 63x. 42 divided by 7 is 6, so 6 times 4 is 24. And then 42 divided by 3 is 14, and then you could solve that equation from there. Okay, so that's method one. So method one is just get rid of your fractions and then you'll be able to just solve that like normal. Okay, method two, using again this sort of idea of a fraction. So method two, the idea is that you would just get a LCD, a least common denominator between all three of these. So the same idea of this LCD of 42 up here, but what we would do instead is I would say, well, let me multiply these guys top and bottom by 21 so that I get 63 over 42x. And I'd have to multiply this guy top and bottom by 6, which would give me 24 over 42. And then I'd multiply this guy top and bottom by 14, which would get me 14 over 42. And then once you have all common denominators, you can essentially ignore the denominators and just solve this equation in the numerator, which you'll notice is the same equation that we had on the last method. Okay, so that's method two. Personally, I prefer to do this way just because I think it's a little bit neater. It's a little less writing. So that's kind of what I like about it. Okay, and then from there, method three. Method three is using cross multiplication. Okay, so cross multiplication, you remember how to do that. You would use that in a situation where you have something where it's only two fractions, right? And then you would just multiply on your diagonals. So it would be 9x equals 5, and then you can solve that pretty easily. Okay, so cross multiplication is another method that works, but you would only do that when you had two fractions set up. So for example, this guy I could use cross multiplication for. I would never choose to use cross multiplication in an instance where I had x's that would need to be multiplied together. So like this one, I would have to multiply the x and the 3, and that one I'd multiply the 2x and the 2. But I'm not going to end up with any exponents on my variable. If, say, this had been a 2x up here, I would not want to do cross multiplication just because I find that to be a little bit trickier. Okay, so let's take a look at these. All right, and we're going to just kind of go through one example of each method so you can kind of see it done out. And then from there, I'm probably just going to stick with my own method. So let's start with method one. So method one, get rid of the fractions. Okay, so the idea here is you're going to figure out what your LCD is, which in this case would be 4x. Right? So I'm going to figure out that my least common denominator would be 4x because I can multiply all of those things up to get 4. Okay, so then I'm going to multiply the entire equation by that LCD. Okay, so taking it one term at a time, 4x times 3 over x, right? The x's would cancel each other out, right? So I would just be left with 12. Okay, 4x times 5 over 2. Well, you could cancel that 2 with one of the 2's here. So I'd have 2x times 5, so 10x. And then this guy, the 4x's would cancel out, and that would leave us just 7. Okay, so whenever I do these ones where I'm getting rid of the fractions, I always start by dealing with a denominator because you're going to be able to cancel some of it out and then multiply by the numerator. All right, and then that leaves us with a really easy equation to solve. Subtract the 12 from both sides, divide, and x equals 1/2. Okay, you do always want to double check for any extraneous solutions. Okay, and the key thing that you would be looking for in this case that would cause you to have an extraneous solution, that would be if you have 0 in your denominator. Okay, so anytime you end up with a 0 in the denominator, that is a mathematically impossible operation, so that would be an issue. But we're okay here. We'd have some fractions, it would simplify out, but we're okay. Okay, so that's method 1, and like I said, that's my preferred method. All right, so now let's look at method 2. So it's pretty similar. We're gonna start by figuring out our LCD. Right, I'm gonna stick a 1 under this just so everything's fractions. And in this case, my least common denominator would be 4 times x plus 4. I'm not gonna actually multiply it out. I'm gonna leave it in that factored form. Okay, and then I'm gonna multiply each term so that it has that common denominator. So this guy is gonna have to get multiplied by 4 top and bottom. The 2 here, we would have to multiply by 4 times x plus 4 top and bottom. And this guy right here, I would just have to multiply by x plus 4, top and bottom. So that would leave me with 12 over 4 times x plus 4 plus, okay, I'm going to do kind of the distributive property here, right? So 2 times 4 would give me 8, and then I have to distribute that 8. So it would be 8x plus 32 over 4 times x plus 4, right? And then that's going to equal x plus 4 over 4 times x plus 4. All right, and then once we have it in a spot where all of our denominators are equal, you can essentially just ignore the denominators and solve the numerator. So I can just kind of pull this out and say, okay, let me solve the equation 12 plus 8x plus 32 equals x plus 4. All right, and this shouldn't be too bad. So grouping together, I'm going to get 7x over here. These two add to 44. Subtract that from both sides. That would be negative 40, right? So x is going to be negative 40 over 7. And there's our solution. Okay, so that's method 2. All right, method 3 is using cross multiplication. So method 3. Okay, cross multiplication. So you don't need an LCD. All you're going to do is just multiply the things on your diagonals. So x times 3 is 3x. And on this side, we'd have to do a distributive property. So I'm multiplying 2 times 2x minus 1. So that'll be 4x minus 2. Right, and then a quick and easy solve, it would be x equals 2, right? And there's our solution. Okay, so cross multiplication can be a really nice method to use sometimes. But again, if I had had like a variable here or a variable here, I wouldn't have wanted to do that because you'd get the same answer, but you'd have to go through like a quadratic to do it. And if you can avoid the quadratics, then by all means do so. Okay, so those are kind of your 3 methods, but like I said, I prefer method 1. That is the one that I like. So that's the one that I'm going to be using for the most part. But these other methods are just sometimes nice to have in your back pocket for when you need them. Sorry, I'm having a lot of trouble getting this paper lined up in the right spot today. Okay, so I'm going to switch back to method 1, and I'm going to take a look at this guy. So my LCD for this would be the x minus 2 and the 3, right? So I'm going to multiply this whole equation by 3 times x minus 2. Okay, so multiplying this first term, the x minus 2's would cancel. So 3 times 2 is 6. Okay, this middle term, the 3's would cancel. So I'm going to multiply negative 2x times x minus 2. So I'm going to go ahead and just write that out for now. And then this last one, the 3's would cancel, and I would have to multiply x minus 2 times x minus 3. Okay, now what with this guy, the big thing to watch out for is make sure you distribute the negative sign with it. So when you do this distributive property, you're going to end up with negative 2x squared plus 4x. Okay, so watch out for that because you have a minus sign here. You need to subtract everything that ends up in the numerator here. Okay, and on this side, that's going to square out to x squared minus 5x plus 6. All right, and we're going to end up with something quadratic. So I'm going to take everything here and move it all onto one side. I'm moving them over to this side because that way I'm going to end up with a positive x squared term. So it'll be 3x squared minus 9x. And then the 6's are just going to cancel each other out, right? So luckily, that's a pretty easy factor. It's got a GCF of 3x. So my two possible solutions are 0 and 3. Okay, and then just do a quick check. Make sure none of these are extraneous. So if I plug in 0 or 3 in the denominator here, am I going to end up with 0? Nope. So we're all set. Okay, let's take a look at this next one. So, yeah, I'm just really having trouble with spacing things out today. There we go, that works. Okay, so this guy right here. So this I know factors to x plus 3 times x minus 3. So I'm going to kind of make a note of that to myself. Okay, and then I can see from here that I'm going to have the x minus 3 and an x plus 3 as my denominator, right? Or my least common denominator. So I'm going to have to multiply this whole thing by x plus 3 times x minus 3. This term, denominators cancel nicely, so that's going to leave me with just 30. This one, the x minus 3's will cancel, so that's going to leave me with 5 times x plus 3. And then I'm going to have minus, nothing's going to cancel, so it'll be minus x plus 3 times x minus 3. Okay, but you know what I'm actually going to do is I know x plus 3 times x minus 3, right? I got that from right here. I'm just going to write x squared minus 9 instead. Save myself a step. All right, so now we're going to simplify this. So two distributive properties. It'll be 5x plus 15. Make sure you distribute that subtraction to both terms. That is a common mistake. All right, I'm going to move everything over onto this side. So I end up with a positive x squared. And then we'd have minus 5x. And then 30 minus 15 would be 15. Minus 9 would be 6. So that'll be plus 6 equals 0. That factors to x minus 2 times x minus 3. So my two possible solutions are 2 and 3. Okay, when I go back and check this, if I plug in 2, that's not going to make any denominator 0. But if I plug in 3, it will, right? If I plug in 3, that denominator is going to be 0. So this guy is extraneous. Okay, and our only solution would be x equals 2. All right, lovely. One more to go. So this guy over here. So I'm going to start by just factoring this. That's x minus 1 times x plus 1. So my least common denominator for the whole thing would have to be x minus 1 times x plus 1. Worked out pretty nicely. So this one, the x plus 1's would cancel, and that leaves me with 4x plus 1 times x minus 1. The middle terms, nothing cancels, so it's going to be minus. And then again, I know that this multiplies to x squared minus 1, so I'm going to go ahead and just write x squared minus 1. And then here, the whole thing would cancel, and that leaves me with just 12. Okay, so then doing some distributive properties. So this guy, I'd end up with 4x squared, let's see, minus 4x plus 1x, so minus 3x, minus 1. And then we'd have a minus an x squared and then a plus 1. Again, distribute that negative there. All right, clean this up, get everything on the same side. I'm going to end up with, let's see, 3x squared minus 3x. Those ones cancel each other out, so it'll just be minus 12. That has a GCF of 3, so let's go ahead and pull that out. Two things that multiply to negative 4 and add to negative 1. Let's see. Not thinking of any off the top of my head. Oops, I figured out why. I messed it up. Back here, there was a 3, right? See, this is why if I was teaching this with actual people, you'd be like, Miss King, what about the 3? Totally forgot to copy the 3 down. So that's going to change things a little bit because now this will be a minus 3x and this will be a plus 3. So, ooh, that's nice. That's just going to cancel this out to a regular x squared. And then let's see, negative 1 plus 3 would be 2. When I subtract the 12, that would be a minus 10. So, oops, my bad. All right, no more GCF. Two things that multiply to negative 10 and add to negative 3, negative 5, and positive 2. So my two possible solutions are 5 and negative 2. Quick check. Not going to make any denominator 0. So we are all set with our solutions. So, moral of the story is, don't forget the numbers that you're supposed to be multiplying by, okay? And make sure you distribute that negative. That is a really common mistake.